In this video, I'm going to show how to set up a simple fixed-wing aircraft design using MAVRIK's component system. MAVRIK has a variety of different components that a user can use to build up a vehicle completely from scratch. This is the vehicle that we will be showing how to build. You can see it's made out of these various components, and we're able to visualize this with this wireframe viewer. As we'll show, this component build-up functionality is very useful inside of MAVRIK, especially for early design phases where detailed models of the vehicle aren't yet available. Today we're going to show that we need no aerodynamic information in order to get this vehicle to fly, just estimates on the overall size of the component. MAVRIK will estimate the aerodynamics and the mass properties of each of these components internally, but these models can be replaced with higher fidelity models such as CFD and wind tunnel when those become available. Follow-on videos will go over more advanced features of MAVRIK using this component functionality, such as making morphing aircraft that can transition and change the geometry in real time. But today we're just going to focus on this very simple fixed wing vehicle where I will be working through setting up the MAVRIK input files in real time. Let's take a quick look at the documentation for MAVRIK. We'll refer back to this when we're throughout the vehicle development process. But here we're going to want to scroll down to the component objects, where you can read about how these component objects are implemented into MAVRIK. There are a number of different types of components that MAVRIK has integrated. You can see some of them here, and each of these will have some common parameters. So where that component is located, its attitude, the mass or weight properties, and you can also specify some custom variables, but we won't look at that in this video. If the component that you're needing to implement doesn't fall under the supported types that MAVRIK already has built in, you can actually build a custom component. But we won't look at that today. Let's look at some of the default components that MAVRIK has at our disposal. First one is the wing component. This will set up an airfoil wing component, and the specific parameters for this component are listed here. And you'll see that most of these are actually optional. So if you know them, you can refine the model. If not, then MAVRIK will do its best to estimate it using default values. So today we're going to try to use as little of the optional values as possible and just try to make this as simple as possible with just the required values. We'll look at this a little closer when we actually set up a wing component for real. We also have a cuboid component. You can set up a cube, such as if you want to set up a battery, which we'll do later. We have a sphere component. We won't use that today. We will use a cylinder component for the fuselage, and these are the properties that you can define there. There's also a rotor component. So this is how you set up your engine propulsion model. We'll look at that a little later for our vehicle, but you can set up different propulsion models, whether that be an electric propulsion model, which MAVRIK actually has a model for that'll estimate inefficiencies in the system with the battery, the ESC, and the motor combination. But you can also specify different propulsion models um, for whatever motor or engine that you're using. While we're here looking at the different component parameters, I'll note that each of these component parameters can actually vary in real time. So instead of these being constant values, you can actually have them be a function of the state of the vehicle, pilot inputs, equations, such as sine equations, etc. So look at that in a different video, but what that allows us to do is have changing geometry in real time. So such as for this wing component, we can actually vary the wingspan, the thickness, the sweep, any of these parameters in real time, which is really powerful for setting up non-traditional aircraft. All right, let's start building our vehicle. First, let's understand our file structure. So you'll have your MAVRIK executable here, your license file. Then there'll be a connections file, and this is what you use to set up different connections with um, various communication ports. So Here I set up a data logging file and then an Unreal Engine type to visualize the flight in the Unreal Engine visualizer. I just have a generic graphics UDP port that we'll send to our wireframe that we'll use to verify that Maverick is building our vehicle properly. And then I also have a PX4 connection that will set up a hardware in the loop connection with a Fixhawk autopilot so we can fly this around later. Then I have a folder for my wireframe viewer. You don't need to worry about that for now. You'll have your main input file for Maverick. This will tell it how to set up the simulation. Um, we won't cover most of this today. That's not the scope of this video. But we'll talk about a little of this later. What we'll mainly focus on is this vehicle properties file. So if I go back to the main input file, I'm telling it that the vehicle properties can be found in this JSON file. And within this vehicle property JSON file, there's three main sections. One is a components. This is where we're going to define each of the components that make up our vehicle, some reference values, and our control effector. So let's dive into actually building our vehicle. So let's start with our fuselage first. I'm going to call this fuselage. You can call these whatever you'd like. We need to specify the type. And I'm going to make this a cylinder. And I need to specify the location. And Maverick is really smart about how it handles units. So if I just put the parameter name, it will default to whatever the default units are that Maverick expects. If I want to specify the units, I use square brackets, and then Maverick will automatically do the unit conversion for us. So I'm going to use feet, but if I wanted to do meters or inches, then Maverick will automatically do the unit conversion for us, which is very convenient. So I'm going to specify the location here for the fuselage. I've worked through this before. We have some good values to play with. Lengths. So it's going to specify the length of my cylinder. And Maverick uses the traditional aircraft coordinate system. So X is out the nose, Y is out the right wing, and Z is down. Specify the weight. I want this the weight that I want this component to be. And then this parameter, include aero, will tell Maverick to include the aerodynamics with the overall vehicle. Since this fuselage is in the main airstream, we want this to be set to true. But later we'll see when we set up a battery that will be internal to the fuselage, we actually want this to be false because we don't want to include the aerodynamics for a component that isn't in the actual flow, airflow. Okay, that's fuselage. And I'm pulling each of these parameters from the documentation that we just looked at. So you can find those there. Next, let's do the main wing. I'm going to set this to type wing. And first I need to set some of the common parameters just for any component, such as the location again. And I'm going to make my main wing actually the center of the vehicle. And specify the semi-span as 4 feet. Now let's take a look at the documentation for a wing component again. And so one of the parameters is side, and you can specify both right or left. If you don't specify this, it will default to both. And what this will do is this will make a right and a left component. And so when we set up our vertical wing, you'll see later an example of why we want to set just one of these instead of both. Um, but since I'm not specifying that, that defaults to both. So that influences our semi-span there. Next, I'm going to set up the chord for our wing. And I'm actually going to make this an array here. And what this will do is this will taper the wing. So this first number sets the chord of the root of the wing. So near the fuselage, the wing will have a chord of 1 foot. Out at the tip, it'll actually be a little smaller at 0.75. So this will taper the wing out to the tip of the wing. Set up the thickness. And this is a percent of the chord, so this is actually 12%. I'll specify the weight of our wing, set that to 2 pounds. And then the two required aerodynamic properties currently are these two for our wing component, but I'm just going to set them to 0. We're trying to make this vehicle, I'm trying to set up this vehicle in terms of if we only knew the geometry we wanted for this vehicle and if we currently didn't have any information about the aerodynamics. I want to set up a control surface for this component, and I want to link it to aileron. We'll actually create the aileron control surface later, but we did to link it to that control surface. And I'm going to say, oh, I need a comma there. And I'm going to say that the control surface should not be symmetric. So what this will do is, since this wing is having both sides, a left and a right half of the wing, it will create an aileron for each side, and we want these to deflect oppositely. So we'll set that to false. For the horizontal tail that we'll do next, for the elevators, we actually want them to deflect the same way, and so we'll set that to true. And this last parameter I'll specify is include arrow. Set that to true. And we're done with our main wing. Let's just take a quick look back at the documentation. And so what we've done is we've set up, so remember each component has some common parameters. So we've set the type, the location. We're not messing with the attitude for these, so I don't even specify that. And we set the weight. And then for the wing component, we specified these required values. So semi-span, chord, thickness, and these two required aerodynamic properties. But we actually just set them to 0. And then we've specified that we want to include the aerodynamics for this vehicle. And then we've also specified control surfaces and whether or not the control vector is symmetric across the right and left sides. So you can see there's more parameters that you can actually set if you know more about the geometry or aerodynamics of your vehicle. Such as if you wanted to specify the specific size of your aileron, you can do that. Right now, it's just assuming it's the full length of the wing. Okay, that's our main wing. Next, let's do the horizontal wing, and I'm actually going to just copy what I've had before since this is pretty identical to the main wing. But let's talk through it. So I've called this my horizontal wing, is in the back for our elevator type wing. The location, I put this backwards. Lowered the semi-span, and I don't want this to taper, so I'm just going to set this to 0.75 for both of them. I made it a little thicker, because why not? Lowered the weight. Still set these to 0, just for simplicity, and then I've tied this to the elevator control surface that, again, we'll set up later. And since I want the left and right side of the wing to deflect the same way, I've set this to true. I want to include the aerodynamics of that component. Okay, now let's do our last wing component, which is our vertical wing. And this is going to be very similar, but there's a couple of new parameters that we've set. So this is still type wing. And now instead of allowing MAVRIK to specify both for this by default, we've set this to left. And then to get this to be a vertical wing, I've set the dihedral to 90 degrees. So it's only taking the left side of the wing and rotating it up 90 degrees. You could also specify the attitude of the component with the common parameter to rotate it vertically. but I prefer this way. But there's multiple ways to do it. Still have our location, our semi-span, cord thickness, weight. These aerodynamic properties are still 0. And I've tied this to the rudder control surface. And I've set this as true. Actually, this won't actually do anything here um, because we've only specified one side. This only affects both. Okay, that's kind of our main vehicle. So we have our fuselage, our main wing, our horizontal wing, and our vertical wing. And here's some reference lengths that you need to set. The area here is just the area of the main wing. The longitudinal length is the mean aerodynamic chord. You can look up the equation for that for a tapered wing. And then the lateral length is actually the full wingspan. We're going to verify that we set up these components correctly in MAVRIK here in a second, but in order to do that, we need to set up our control effectors first. And so the way we do that is we need to make sure these are called the same thing that we linked to in these components. So we'll set up an aileron control effector, and I'm going to set the magnitude limits that in degrees. And since these ailerons span the full length of the wing, they're going to be pretty effective. So I'm just going to let them, I'm only going to let them deflect plus or minus 5 degrees. And so MAVRIK can handle 0th, first, and second order actuator dynamics. So here, this would just be 0th order. I'm actually going to do second order actuator dynamics since that'll be the most accurate. And so I've specified a couple other parameters here. So we had magnitude limits, rate limits, how fast the actuator can move, the natural frequency, damping ratio, and acceleration limits. I'm going to just copy in the other control effectors since they're pretty much exactly the same. But we'll look at them really quick. I also have elevator. I've found this between plus or minus 15 degrees of deflection. I have my rudder. This is plus or minus 30 degrees. And I also have a throttle. We haven't set up the motor yet, but since we're here, we'll just complete this. So we have throttle, and this is set up to be first order dynamics. So we have our magnitude limits just from 0 to 1 for a tau, and then rate limits, and then I've specified a time constant. So really quick, you can see how this is set up in the documentation. If we look at vehicle dictionary, um, we've set up, so we've been looking at setting up the components, the control effectors, and the reference lengths areas. Those are some descriptions are there. But for the control effectors, here here's some more descriptions of each of these. So magnitude limits, natural frequency, and how you set these up for whatever actuator dynamic model that you like. Okay, next we're actually just going to run MAVRIK so that we can verify that we set up our vehicle properly. The way we do that is in our main input file, we can set up this analysis section. So let me collapse this so you can just see where you do this. Um, so you'll set up analysis in this directory. And there's a number of things MAVRIK can do. I have a couple of these just X'd out for now, but what we're interested in right now is creating a VTK file. And so this will output a VTK file, and our wireframe viewer can then open this VTK and we can see what our aircraft actually looks like. So I'm going to run MAVRIK. I'm just running it in this terminal inside of Visual Studio, but you can use whatever terminal you prefer, such as Command Prompt or PowerShell. So typing in MAVRIK there, and then I'm going to go into my fixed wing folder and tell it where my main input file is. Run that, and it actually stopped because I don't have the Pixhawk plugged in for hardware in the loop. but it generated this VTK file, which is what we want. So um, for our wireframe viewer, I've already told it where to open up this VTK file. So I can run this, and let me make this a little bigger. And now we can actually look at our vehicle in terms of how MAVRIK um, built up our vehicle with what we defined. And so you can see it looks pretty good. We can see our main wing does taper a little bit. You can see where our horizontal and vertical wing are and our fuselage. And since this is just a wireframe viewer, it can be a little hard to tell if things are solid or not, but our fuselage is solid. And so the overall geometry looks pretty good. Let's proceed on adding our motor and a battery component. So we'll go back to our vehicle file. And now let's add an engine. I won't focus too much on the engine for now. It's a little to cover in this video where we're trying to keep it simple. Um, but you'll be able to copy in exactly what I have here. What I've done is I've set up an electric propulsion model for a specific propeller and electric model with a specific battery. So I specified a rotor type and these properties here. You can see the number of blades for the propeller and the rotation direction. And for the actual motor, I've set up the electric propulsion model. So I'm using a battery where I can actually specify the number of cells that are in parallel in series, and then the properties of those cells. So the capacity, resistance, and then since MAVRIK is estimating the electric circuit of the propulsion model, it actually has these various parameters that we can specify, such as efficiencies and resistances. But this is a little much to cover right now. I've specified the aerodynamics for this engine here, just very simply. So feel free to copy this if you're following along. This is just a pretty good default model for what we're doing. But you have a lot of control over how you can define this engine if you're using a hybrid setup or a gas engine or whatever kind of propulsion model that you want to include. So there's our engine. I forgot to mention that we're actually tying the motor to our throttle control. And so this will tie it to this throttle control effector down here. Okay. Lastly, let's add a battery. I'll do this manually. I'm going to call this battery, and I'm going to specify that the type is a cuboid. And I'm going to put the location in feet at this location around where the main wing is. Specify the lengths. And specify weight. And since this battery is inside the fuselage and not in the airflow, we're actually going to not include the aerodynamics for this component. So the MAVRIK will include the inertia and mass properties of this component, but not the aerodynamics. Okay, so we've added the engine and the battery. Let's rerun our VTK and see if these were added correctly. I'm going to run MAVRIK again. I should have updated this VTK file. Rerun the viewer. And now we have our motor on the front. So for our rotor, MAVRIK just puts a disc for where the propeller is spinning. So that's on the front. That looks good. And then we could see it actually added a rectangular battery right in the middle of the fuselage there. Okay, and that's our completed vehicle. So next, let's test how this flies. Let's take a look at a couple properties in our input file. So we're saying that our simulation should run at a ground altitude of 0. That's fine. For our turbulence, we're going to have a little bit of a constant wind and some turbulence with the sigma value here. For our vehicle, we're going to set up our vehicle with this initial state. And we're actually going to have this launch. So I'm going to increase this so we have a little time. But the vehicle will sit until 60 seconds, and then MAVRIK will launch the vehicle. And after 0.5 seconds, the vehicle will be at this state that we defined. Okay, that should be it. Like I said before, I'm going to be running this with PX4 and hardware in the loop. So if you're interested in that, you can copy what I have here exactly. You're going to need to change your serial port number. So I'm going to plug in my PixHawk and let that connect. And open up Q ground control. And then I'm going to run MAVRIK. Yep, looks like MAVRIK's running. And we'll take a quick look at how I have PX4 set up. Even though this isn't the point of the video, just to be complete. So showing that it's ready to fly, let's look at how I have the setup in here. So I just have a standard plane. And then in safety, if you scroll down, you can enable hardware in the loop right here. And you'll need to restart if you change that. Actuators is our main parameters that we want to set up. So we have one motor, 3 control surfaces, and I've just specified a left aileron, an elevator, and a rudder. And then for hardware in the loop, we want these to be in the same channel order that we set up the control surfaces in the MAVRIK file. So in the MAVRIK file, we set up an aileron first, then an elevator, then a rudder, then our throttle. So these should be in the same order, so MAVRIK applies those correctly. And then for just sign conventions, I needed to reverse the elevator and rudder directions. Okay, that should be it. Okay, I've organized my screens just to be a little easier to see. I've replugged in my PixHawk. I'm going to start MAVRIK. Reading in the parameters right now in Q ground control. But we can see our vehicle. Here it's sitting at a 15-degree angle of attack, or elevation angle, that we defined in our input file. I'm just going to fly this in manual mode and arm the vehicle. And so now MAVRIK is just sitting, waiting to get to our launch time, which I believe was 60 seconds. And then it'll launch the vehicle. So in this wireframe viewer, it doesn't, the way I have it set up, it doesn't have the control animations, but we could also, if we made this vehicle inside of Unreal Engine, we'd also be able to see all the animations of the control surfaces. Okay, MAVRIK just launched the vehicle, and we're able to fly around now. So I just have a USB radio plugged into my computer that you can set up Q ground control to use that instead of uh, a normal pilot radio receiver into the PixHawk, but you can do either. See, I'm flying around, so our design is pretty good, not too bad. I did tune these values beforehand to make sure this actually flew well. But our control surfaces are moving the correct way. Our motor is working. Let's try to do a barrel roll. Go. like I flew outside of my geofence, so now it's in a hold mode. But yeah, our vehicle is flying. So this is just a very simple fixed wing aircraft. The next video we're going to look at a quadcopter, and then future videos will show some advanced features such as making this fixed wing design actually morph in real time. So we're going to change the span of the wing, the sweep, the dihedral, and make the geometry change in real time, which is really cool. And so this has been an introduction to MAVRIK's component functionality. So you saw that we had no information about the aerodynamics of the vehicle, just basically geometry, sizing. And so within minutes, we were able to create a vehicle that we can actually fly around and that we could use to develop control laws and test other aspects of the vehicle without investing a lot of time and effort into CFD and wind tunnel. But once we have that, we can actually replace our vehicle model with those higher fidelity models. The component nature of MAVRIK, we used it to build up our vehicle here, but you can also use it to append on whatever you want. So if you had a camera or a different payload that you wanted to see how your aircraft responded to, you could easily add that here. So let's say we had this fixed wing model here, and we wanted to see what would happen if we put a nacelle or a camera out on the on one of the wingtips. How would that aircraft respond? Could the autopilot compensate for that extra component? We could easily test that here in MAVRIK. So, but yeah, hopefully this was informative as an introduction to how MAVRIK vehicles can be built up using components. And we'll see you in the next video.